And I'll go ahead and I'll do I'll just talk about this one first, number 20. Just remember when you mark on your syringe, what they're really wanting to know is that, what are you drawing up first? And I think at this point, we all know that it's the regular insulin is drawn up first. So you would say 22 units regular first, and then you would mark at the total. So 22 plus 36 would be 58. So if I'm marking this syringe, according to the textbook, we're going to look at the syringe. So I'm going to say 50, then 2, 4, 6. So I'm going to make a mark at 56. And I apologize, I'm doing this with my mouse and I might not be right on 56, but I think we're close enough. So that's your total. And I would indicate that by saying, by indicating and saying that that is the total amount. So I'm abbreviating that T. Your regular insulin, because it was drawn first, is actually going to be 22 units from the total mark. And that 22 unit mark is actually at the 36. So I'm sorry, that was supposed to be 58, not 56, sorry. Okay, let's try that again. But he corrected me. All right, so 22 and 36 is 58, not 56. So my first mark, or my total mark, would be at the 58. So 58 units total, and I'd abbreviate that T. And then between 36 and 58 is hypothetically where the regular insulin would exist, because that would be, it was drawn up first, and then the 36 units technically pulled it up. And so the way I would indicate that is I would put a mark at 36, and then I would put like a representation that this is my regular insulin. And then I would even add that this over here was my NPH. So if I'm answering this question, that's how I would mark the syringe. Don't forget to select it. And then as a reference point, there are textbooks, or in one of the textbooks for for dosage calculation, it shows you, this is an example of 10 units Humulin R insulin and 30 units Humulin N, and they show how to mark it. And they show that the regular would exist hypothetically between the plunger end of the syringe and then the new injection. In reality, it all mixes together, so you wouldn't really see this in a real life situation. But if you've ever missed this question, you probably missed it because you marked it wrong. And what is tricky is the fact that it asks you to do those 2 arrows, and in reality, you should probably have more information listed on there. So I would say it probably makes more sense to just mark it up and make sure you are putting all the information on there. That way you don't miss it because you forgot to include something. And then if it's me, when I'm on the I went to the screen. Nope. Sorry. If it's me, I'm writing right next to where it says solution amount to be drawn up first. I'm writing 22 units regular insulin first, and then I'm writing 58 units total, and then I'm marking the syringe as I showed you previously. So that's number 20. Number 25, this is your heparin protocol. You've seen this. You saw this last semester. You know that on your tests, you're going to get the patient's weight is the thing that's going to differ from the rest of the protocol, and then everything else is just kind of following the steps of the protocol. I went in and I highlighted the important areas, and I crossed out the areas you don't need to worry about filling in for the math portion of the heparin protocol. And then these are the questions. And if you recall from last semester, you're only going to get 2 of the 4 questions. It's one question, but it has 2 parts. You need to get both parts right to get full credit for the question. If you miss one or both parts, then you've only missed 1 question. So what we're going to do is I'm actually going to do this. I'm going to use for this review, I'm going to go ahead and use a different patient weight and just show you what that might look like. So I'm going to use, let's do, as an example, I'll write it down. Let's use 184 pounds. All right, so if the patient weighs 184 pounds, we still need to do the first step and calculate and convert that to kilograms. So 184 divided by 2.2 will give me 83.636363. So I'm going to go ahead and round that to 83.6 kilograms. So my patient, going through the heparin protocol, my 184-pound patient, the step 1 is we have to convert the patient's weight in pounds to kilograms. Then I'm going to go back and I'm going to look at my questions for this. It tells me that I need to calculate the number of milliliters to administer for the bolus. I need to calculate the infusion rate for the milliliters per hour for the heparin IV drip. In order to do that, I need to know where I'm starting. It tells me within the protocol that we're going to bolus with 80 units per kilogram and then start a drip at 18 units per kilogram per hour. That same information is listed at the start of this question. And then I also need to pay attention to my available. So my heparin, 25,000 units and 215 milliliters, half normal saline. That's what I have available for my IV. So when I calculate the flow rate, that's what I would use in order to calculate my flow rate. Since we're talking about bolus, I'm going to use this information, the 1,000 units per milliliter, because that's what it tells me. The bolus dosage strength is 1,000 units per milliliter. So step 2 is to bolus with 80 units per kilogram. So, and as a reminder, step 1 was convert pounds to kilograms. All right. So for part A, in this example, I'm going to take my 83.6 kilograms, and I'm going to multiply by the 80 units per kilogram. I'm going to take 83.6 times 80, and I'm going to get 6,688 units. Now, I don't want units, I want milliliters. So I'm going to use my bolus dosage strength of 1,000 units per milliliter. So if you want to put the 1,000 units underneath the 6,688 units, that's perfectly fine. I'm going to write it out dimensional analysis wise. But if you want to do the ordered over half, your order would be the 6,688 units over your half, which is the 1,000 units times the milliliter. We'll get the same answer, which is 6.688 milliliters. And we're just going to round that to 6.7 milliliters. If you had chose to leave if you chose to do your rounding at the very end, so like where I had the 184 pounds divided by 2.2 and I got the 83.63 repeating, when I multiply that number by 80 and divide by 1,000, I would get 6.69. So you still get the same answer of 6.7 milliliters. So I just wanted you to know that you'd still get the same answer. All right, step B. or part B. For part B, we're going to be calculating the heparin infusion rate for our same 184-pound, 83.6 kilogram patient. When we look at the protocol, it says we need to start a drip rate at, or a flow rate at 18 units per kilogram per hour. So that's the next step. So I'm going to take my same patient, same weight, 83.6 kilograms, times the 18 units kilogram hour. I'm going to put that into my calculator. 83.6 times 8 times 18. And I'm going to get 1,504.8. This is units per hour. Then I'm going to convert units per hour to milliliters per hour. In order to do that, I need to know what I have available for in my IV. My IV says I have heparin 25,000 units in 250 milliliters, half normal saline. So that's what I'm going to use. I'm going to use the heparin 25,000 units in 250 milliliters, half normal saline. So there's two ways you can do this. You could put the 25,000 units underneath, multiply by the 250 ml. Again, I'm going to write it out dimensional analysis wise. 250 ml, 25,000 units. And when I do that, then we get 15 or 1.5. Let me see here. No, 15.04. So 250 25,000. And yeah, I'm going to get 15.048 milliliters per hour. And again, you would want to round that to the nearest tenth. Problem is, we don't have, this number is quite small. So I'm going to go ahead and just say 15 milliliters per hour, because you wouldn't necessarily round 4.8 up to 1. This needs to be 5.0 or greater. So my recommendation would be just to leave it at 15 milliliters per hour. If this were 15.078, then yeah, you could say 15.1. I was having the conversation earlier with another student that says, like, you know, on an infusion pump, you probably can't even program in the decimals, but on the math test, you know, they want you to round to the nearest tenth, unless we're talking about a drop, and drops, you can't give someone a decimal drop. All right, so that's how you would solve the two questions or parts A and parts B for the heparin protocol. And I'm sorry, did someone start? Go ahead.
For milliliter per hour, should we round it, or we don't have to round it?
This would be the answer, rounded, 15 milliliters per hour.
Yeah, if it was, for example, 15.1, we should 0.17, something like that. Should we round it? Usually, should we round it, or we don't have to round?
Round to the nearest tenth.
Okay.
Yeah, you do want to round to the nearest tenth. Hopefully you won't have a question like this where you have like decimal answers, but if you do, round to the nearest tenth. Show your work, round to the nearest tenth. All right, let's go on to the next part here, which is the, you look at the patient's APTT after 43 seconds, and we're going to have to do some more work. We see that because of the range, we're going to rebolus with 40 units per kilogram, and then we're going to increase the rate by 2 units per kilogram per hour. And so we know we're going to give them half of what we gave them initially. And then we also know that we're going to increase the rate. So the initial rate was 18. Now we're going to increase it to 20. And so let's go ahead and figure or work that one out. So I always like to say, we're still talking about the same patient. Okay. So they still weigh the same weight. But now we're going to use different variables to get to our new answer. So I'm going to take that 83.6 times 40. And that's going to give me 3,344 units. And then we're going to use the bolus dose strength again. And I'll show this to you the ordered over halfway, 1,000 units times the 1 milliliter. And we'll get 3.344 milliliters. And we would round that to 3.3 milliliters. So your bolus dose after the 6 hours, after we've assessed their clotting time, we're going to then now rebolus with the 3.3 milliliters. And then for part 2, C part 2, same patient weight. Now remember, initially it was 18 units per kilogram per hour. Now we're going to increase it to 20 units, or by 2. So that's now going to be 20 units kilogram hour. So 83.6 times 20 is going to give me 1,672 units per hour. And again, I'll just show you the alternative way. Remember, our heparin was 25,000 units heparin in 250 milliliters, half normal saline. So if you're going to do ordered over half, just make sure you're putting your variables in the right places. And then I'm going to get 16.72 mil per hour. And you'll go ahead and round that to 16.7 mil per hour. In reality, you might actually round that to 17 milliliters per hour. But from what I understand, from what you guys are supposed to be doing on this test is when it is like milliliters per hour, things like that, that you would round to the nearest tenth. And I haven't heard other than that. So that's why I show it to you that way. My guess is that on your actual test, though, you will have your answers should come out. So you don't have to worry about the rounding aspect of it. You just need to know how to get to the answers. Any other questions? Yes, that is correct, Nathan. So Nathan said they've always said round to the nearest tenth for answers over 1 and nearest hundredth for answers less than 1. That is correct. The exceptions obviously are going to be when you're doing your basic unit conversions, so milligrams to grams, micrograms to milligrams, things like that, as well as when you're dealing with drops. You cannot give somebody a tenth of a drop or a hundredth of a drop. But when we're talking about, like, I would say that probably makes the most sense for your injectables. So if I'm doing like a if I have a syringe, I can have a syringe that goes all the way down into the thousandth place. So all that's, all that stuff can be flexible depending on the how it's being administered. But like if you get an answer of like for an intramuscular injection of 0.75 milliliters, that's your answer because it's rounded to the nearest hundredth place. If it were, if all you had was 0.2, then that's your answer, 0.2. So, but you are correct. And then that's what it even states, I think in the packet, it tells you the rounding rules as far as that, but there are just a few exceptions. All right, I'll give you a few minutes. You can just look over and see if you have any other questions. I would say the most things that people are asking so far for 240 have been this question, and then some of those questions earlier on in the packet. But if you feel like you got a good grasp on them, there you go. I knew somebody was going to say number 8. So let's go ahead and work through that. So the challenge with number 8 is that you basically have you have to do a couple conversions to answer number 8. I already did number 25, so I won't do that one again, Kayla. But I will, and I'll just tell you, like, this will get posted on Blackboard, or I'm sorry, on YouTube, so you can watch the review. But I will show you the other numbers there. But I just finished up doing 25, so you can catch it on the replay. All right, for question 8, a couple of things. You're going to be doing some converting. So you have a couple of things. You have 5 micrograms per kilogram per minute. You have the patient's weight. Thankfully, they're already in kilograms, so you don't have to convert that. You have your available in 400 milligrams per 250 ml. And then they want you to know what to begin the infusion at. So the first question you probably want to ask is, well, what do you mean what the infusion is? So unless we're talking about drops, and there's a drop factor listed, you have to assume that we're looking for milliliters per hour. And so for this question, we are looking for milliliters per hour. Okay. The second thing, you have micrograms and you have milligrams. You're going to have to convert one to the other so that they're both the same. So you need them to both be micrograms, or then you need them to both be milligrams. And I'll show you how I do that. And then lastly, you need to convert minutes to hours. Okay. So ultimately for this question number 8, you're looking for milliliters per hour. You have a rate of 5 micrograms per kilogram per minute, and then you want to make your way to milliliters per hour. So I'm going to write that up, or write up the important parts, and then I'll show you how to set this question up. All right, so this is question 8. So 5 micrograms kilograms per minute. Then we have 70 kilograms. And then we have 400 milligrams per 250 ml.
Excuse me, can you share your picture with us, please?
I will. Hold on one second. Actually, if you click on my video, you can expand it, but I'm going to also do this. I just needed to be able to see it. Now you should be able to see everything.
Thank you.
I do. You're welcome. Yeah. So if you ever are looking for the questions there, or if you're looking to zoom in on like a particular screen, you should be able to just tap or click on the screen that you want to see bigger on your end. But I always will go to the big screen like this. I mean, it's big when I look at it, I guess. So, all right. So the reason I know we're looking for milliliters per hour is 2 reasons. There's no mention of the microtubing listed here. Okay. And there's also no mention of, there's no mention of microtubing or tubing or of anything like that. And so when we're doing and calculating infusion rates, we're looking for milliliters per hour. So that helps things out. So, at least in my mind. So step 1 is I need to account for the patient's weight. So I'm going to multiply the patient's weight by the order, which is the 5 micrograms kilograms per minute, which gives me 350 micrograms per minute. Now you can do this next step later on if you want to. I just, in my mind, it just makes the most sense just to go ahead, since we already know we're working towards milliliters per hour. Let's go ahead and convert minutes to hours. So 350 times 60 is 21,000 micrograms per hour. Now, remember our available is the 400 milligrams per 250 ml. So we have micrograms, we have milligrams. They both need to be the same. So my recommendation is to go ahead and convert the micrograms to milligrams. You probably remember how to do that by just moving your decimal point over 3. But if you don't, you can set this up by just saying, okay, well, I know that 1 milligram has 1,000 micrograms. You do need to know that, okay? And then you are going to get 21 milligrams as your converted dose, or converted from micrograms to milligrams. So it's 21 milligrams. We're still per hour. And then I'm going to convert milligrams per hour to milliliters per hour, doing what you've already done probably hundreds of times at this point. Alternatively, you can say, if it's 21 milligrams per hour, and if you like the way this looks better, your order over your have times the volume. Either way, you're going to get the same thing. And this is where I think a lot of you got an answer. You got the right answer, but then you're probably like, well, why doesn't the key round? Because key's wrong. So that's the easiest answer. So 21 times 250 divided by 400. You're going to get 13.125, which you would just round to 13.1 mil per hour. So if you're like, if you got 13.125, then you did it right. And then you confirmed that, but then you were like, wait, wouldn't we round to the nearest 10th? Yes, you would still round to the nearest 10th. So the key is just, they didn't account for the rounding. All right, so that's number 8. Let's look at number 16. So 16 is a drop rate question that has some extra information. It tells me 500 milliliters. It tells me a flow rate. And it tells me our drop factor. So what is the GTT per minute? So in order to do that, you need 2 pieces of information: flow rate, drop factor. The 500 milliliters of the dextrose 5% or 5W, we don't need that information in order to answer the question. And what I'm saying is, and I'll show you in just, I'm going to do this now, is when we talk about drop rates, I need 2 pieces of information. I need the flow rate and I need the drop factor. Those 2 pieces of information will give me the drop rate. Flow rate is milliliters per hour. Drop factor is drops per milliliter. And drop rate is drops per minute. So I need to know those 2 pieces of information in order to get that piece of information. So it tells me 120 milliliters per hour, which is the same thing as 60 minutes. Drop factor is it 15? 15. Sorry, that wasn't meant to be asking you. I just needed to look, I needed to look back at my screen. And then my answer would be 30 drops per minute. So the 500 milliliters, the only reason you would need to know that is if it told you 500 milliliters over 2 hours and it didn't give you the flow rate. But since it gives you the flow rate, it doesn't matter how much is there. You just need to know the flow rate. Same thing would be said if they told you there was, 450 milligrams of an antibiotic in there. You don't need that when you're calculating flow rates. You only need to know the rate in which it's flowing. And then the silly analogy I use is if you and I are going to meet each other at Kennywood, you're driving your BMW and I'm driving my minivan, we're both going to probably get there around the same time, assuming we left from around the same place, because our speed limits are going to be limited to what we're allowed to travel, even if you're driving a nicer vehicle. I'm just driving something a little bit more practical for my family of 5. And hopefully that makes sense. All right, so that was 16. Number 21. These are good practice ones that help you kind of with what's happening in with 21 through 24. They're good setups for what's happening in the heparin protocol. So we'll look at that. I just want to see what 17 is. Yeah, 17, you would set up the same way, 180 over 60 times 10. All right. So 21 is another drop rate question. So this would be another practice. So 17 and 21 are very similar. Again, we have extra information. So the numbers here are as such. And 10. So in this question, number 21, we have some extra information. We have the Solumedrol 200 milligrams IV. So what? That's how much is in there. It's important, obviously, that we're administering the correct medication. But as far as calculating a flow rate or a drop rate, I don't need to know that. I just need to know my flow rate, 120 milliliters over 30 minutes times my drop factor of 10. Okay, so this would be 120 over 30 times 10, which would be, I think, 40 drops per minute. For 17, same thing as I mentioned before. You're going to take 180 over 60 minutes, 1 hour, 60 minutes times 10, and you're going to get 30 drops per minute. All right. So some of these, like 22 and 23 and 24, are kind of like parts B and parts and part C2 for the heparin protocol, and that you're converting units per hour to milliliters per hour. So let me just write these down real quick so I have them, and I'll write these down. So for like 22, we have 750 units per hour. And I will expand my screen in just a moment. And then we have 25,000 units in a 1 liter bag. And we want to know milliliters per hour. It's 22 for 23. We have 1,250 units per hour. 500 milliliters. 25,000 units again. And then we want to again know milliliters per hour. And then finally for 24, we have 500 milliliters, 100 units, 15 units per hour. And again, we want to know milliliters per hour. All right. So as a strategy, I'm going to recommend that you start with units per hour when you do these problems. And I'm going to show you two ways to do this. I'm going to show you the dimensional analysis setup, and then I'm going to show you the one that looks more like ordered over half. So 750 units per hour. What do I have available? I have a 1 liter IV that contains 25,000 units. So I'm trying to get rid of units and I'm trying to get milliliters. I have 1,000 milliliters, 25,000 units. So before I do anything, I'm already in milliliters per hour, and that's how you would set this up. And then I would just do my calculation. I take the 750 times 1,000 divided by the 25,000, and you're going to get 30 milliliters per hour. Alternatively, if you hate the way dimensional analysis looks, you can also set it up like this. You can take your 750 units per hour. You know what? I need more room. You can take your 750 units per hour over. So this is your order. Your available is the 25,000 units times your quantity, which is the 1,000 milliliters. And you'll get the same answer, 30 milliliters per hour. We would do 23 exactly the same way. I'd still start with the 1250 units per hour. And I'll do this the ordered over half way. I'm going to look at my my available. So I have 25,000 units in a 500 milliliter IV solution. So my available is the 25,000 units. And then times the 500 milliliters. Again, I'm going to take the 1250 times 500 divided by 25,000. And I'm going to get 25 mil per hour. As a side note, if you do 12,050 or 1,250 divided by 25,000 times 500, we're all doing the same thing. Okay, so you should get the same answer, or you will get the same answer as long as you plugged it into your calculator just fine. And then for this one, we're going to take, again, I recommend starting with the 15 units per hour. And then converting units per hour to milliliters per hour using what we have. 500 milliliter IV with 100 units of insulin. And then we're going to get, I think 60, not 60, 75. This be an ml. So you can do 15 times 500 divided by 100. If you did it the ordered over halfway, and you said, okay, what if I do, 15 divided by 100 times 500, you get the same answer. It's still 75 milliliters per hour. So that does not change. Any other questions? Yes, you can miss, so it's 25 questions, you can miss 2. If you miss 2 or fewer, then you will get, you'll pass. If you miss more than 2, if you miss 3 or more, then you will remediate and then you'll take a makeup test. So, but hopefully we won't have to do that. So thought we did 12. Okay, 12. You're just going to take you have a 60 milligram IV. Your available is 25 milligrams per milliliter. So you're just going to do 60 divided by 25. And then maybe the key is wrong. So let's see. 60 divided by 25 will give you 2.4 milliliters. Is the key wrong for that one? Oh, okay. Okay, 2.4. Okay.
Excuse me, 60 divided by 25 is going to be 2.4?
Correct.
Okay.
Yeah, you would just take your order of 60 milligrams divided by the 25 times the 1 ml.
Wait, that's right. Thank you.
Yep, you're welcome. Any other questions? I'll post the recordings will be posted on YouTube. So I posted Tuesday's recordings on YouTube, and then these will also be posted, or this will also be posted on YouTube. You're welcome.
Are you posting it tonight?
I'm gonna try.
Okay.
Yeah, but I will say that I already posted the Tuesday reviews, so the Tuesday reviews are already posted for 240. But I will try and get these posted up tonight. If not tonight,
Is it the same questions you did?
I did 8. I always do the heparin protocol between you guys and the 220, 230 reviews. I do those questions like 21, 22, 23, 24, usually touch on those. So okay. You guys did actually ask more questions this time around. So like I said, I'll try and get this one up as soon as it's available.
Thanks.
But there's a lot of, I mean, even if you go back and look at like the last semester's reviews, you're going to see a lot of these questions are repeated. So yeah, you're welcome. And good. Okay. I'm glad that you know how to do the protocol again. It's good.
Excuse me, for rounding to kilogram or pounds, do we still need to round it, or we don't have to do it? Or
yes, you need to round to the nearest tenth when you go from pounds to kilograms.
Can you refresh my memory on the rounding? Is it if it's like 0 point something, then it's to the hundredths, but if it's like 13 point something, it's to the tenths, correct?
You got it. Yeah. So if it's a number less than 1, you can round to the hundredths place. If it's number greater than 1, round to the tenths. And then the caveats to rounding are you round drops to the nearest whole drop. So you can't give somebody a decimal drop. You have to give them a whole drop. So if you have like 22.6 drops, you're going to give them 23 drops. And then when you're doing your basic unit conversions, like these first few questions, like 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5, when you're going from micrograms to milligrams, grams to milligrams, do not round those answers. Leave them as they are. So like when you go from 0.15 grams to milligrams, that ends up being a big number. But if you were going from 0.15 milligrams to grams, you're going to get a very small number that's like 0.000015. You're going to leave that alone as is. Do not round that up. Just leave it as it is. And that's just for the basic unit conversions.
Okay, thank you.
You're welcome.
Wait, so did she just say for the kilograms you do round it?
Yes.
Okay.
Yeah. So when you're moving in and out of the metric system, that's the only time that you would do some rounding. So if I'm going from pounds to kilograms, so if the 152 divided by 2.2 gives me 69.090909, I would round that answer to 69.1 kilograms. I should say you would round that answer to the nearest 10th as far as that's concerned. But when you're in the metric system though, and you're just doing a metric to metric conversion, don't round those.
Did they tell you like, so if we're doing like the tablet thing and it's like the answer's like half a tablet, are we writing 1/2 or 0.5?
I don't know the answer to that. I've seen both be accepted. So I would just say confirm that with your instructor how they want it written.
Because I think they only accept one of those, but I don't know which one. Okay.
Yeah, that's what I was saying. Like, yeah, if they accept both, it should be fine. If they want it written as 1/2, like you want to make sure you confirm what they want. I would be giving you a guess. From what I understand, they usually prefer the 1/2, but I've also seen where they prefer the 0.5. So I don't know the answer. You're welcome. Yeah, if you do have any other questions, just let me know. If not, like I said, I'll be back for the 240 class this evening, 6:15. And then I'll have these posted. I'm gonna try and get them posted tonight though. So you're welcome.